Introduction to the contents of the first and second chapters.
Prelude to the first section. The origin and development of life. The emergence and development of man and the beginning of the use of primary energy. Historical development and reflections on the history of energy. The age of living energy. Man's discovery of fire. The emergence of the first country in history. The invention of writing. The emergence of the first religious beliefs and its impact on the efficiency of energy use in ancient Egypt. The transfer of the center of civilization to the Greeks, Romans, and then Alexandria. The era of wind energy. The era of running water energy, rivers. Era of steam. Steam machine. Steam locomotives were diesel engines, then gasoline, then jet engines. The beginning of the development of science and its impact on energy efficiency. The relationship between the elements of matter in chemical terms. Interactions. Dmitry Mendeleev and the periodic table of the elements. John Newland and the periodic law of contemporary. Electrical properties. What is electricity and what are its properties? Electric field. Static electricity and its effect. Static electricity veil. Point discharge. Electric wind. Vectors, insulators, semiconductors. Electronic delivery. Resistance or ability to resist. Magnetism. Magnetic field. Earth's magnetic field. The field. Interaction of the domains. Gravitational thrust magnet.
Studying the electrical properties of particles of matter. The roots of the radiological problem. The collapse of the concept of remote influence. The collapse of the human idea of the universe. Electric charge. Further understanding of the roots of the radiological issue. Electron discovery. Marie Curie and radioactivity. The race to know the components of the atom begins. Classification in the periodic table. Modern tables. Table uses. Element properties. Definition of a chemical element. Metals, metals. Nonmetals. Metalloids. Halogens. Lantholides. Physical properties. Actinides. Semimetal. Noble gases.
Geological formation of the Earth's crust. A detailed view of the shapes and data of the elements contained in the periodic table in nature and their areas of use. The nature of radiation waves. The properties of waves from a physical perspective. The speed of sound and the speed of light. First, the sound. The speed of sound as it travels. Sound measurement. Sound waves. Frequency. Wave capacity. Wavelength. Doppler phenomenon. Huge and loudness. Decibel meter. Put out the noise. Protecting people from noise. Audio production and hearing. Musical sounds. Range of sound vibrations and range of hearing. Sound reflection and absorption. Reflective acoustic dishes. Ultrasonic sound. Scale. Audio recording. Electronic sounds. Special effects. Composed voices. Second, the light. Rays. Flame spectra. Emission spectra. Absorption spectrum. Absolute black body spectrum. Black body concept.
Now the radioactivity. Decay or beta decay. Alpha decomposition. Back to Niels Bohr. The discovery of the neutron. More knowledge about the structure of matter. The discovery of the meson and the discovery of the neutrino. What turns an electron into a proton? The properties of the forces inherent in the nucleus. Industrial radioactivity. Cosmic artillery, particle accelerators. At a new crossroads. The neutron splits the nucleus of an atom. The group of isotopes of uranium. Reaching the desired goal. Chain reactions controlled. How do we get an exact chain reaction? Atoms and billiards. Water is heavier than water. First account. Control columns or bars, and how do they work? Torch in lab.
atomic detonation and the atomic bomb. The most important results of atomic research in nuclear reactors to generate electricity. Nuclear fission and nuclear fusion. Nuclear reactors. Uranium in nature. Methods for obtaining a self-interaction chain. Advantages of fertilization. Combustion comparison. Nuclear reactor. The heart of a nuclear reactor. Sedative. Coolant. Control system. Neutron inverter. The bowl. Radiation condom and bioprotection. Reactor building. Barriers and protective shields. Classification of torsional reactors. Plutonium production. Nuclear fuel, the concept of the nuclear fuel cycle. Uranium or beneficiation process. Production reactor fuel cycle. Converting uranium to uranium hexafluoride gas. Uranium enrichment. Gaseous diffusion method. Centrifugal method. Jet nozzle fertilization. Laser fertilization. The possibility of laser separation of uranium isotopes.
What is a laser? Rays of light and the history of the development of lasers. Coherent radiation. Incoherent radiation. The waveform of coherent radiation and incoherent radiation. Distribution of energy levels. Particle and matter waves. Wave mechanics. Basics of laser generation. Backlink. Backlink and plasma. Backlink in semiconductors. Energy belt theory. Electromagnetic bomb. Basics of laser work. Settlement transformation. Sapphire laser. Classification of laser generators. Solid-state laser pumping methods. Solar pumping. Chemical pumping. Frictional gas thrust pumping. Gas laser generators and how to pump them. How gas laser generators work. Neutral gas laser. Helium neon laser. How does the laser start? Free laser blasts. Gas molecular laser. Carbon dioxide gas laser. How to operate. Methods of improving obstetrics. Semiconductor laser. Pumping method, injection. Components and methods of operation. Modular structures of semiconductor laser generators. Efficiency.
Temperature. Thermometer. Absolute zero. Particle speed. Thermal expansion. Heat capacity. Thermal conductivity. Pregnancy. Molecular mechanics. Friction forces. Sliding friction and rolling friction. Viscous friction in liquids and gases. Resistance forces at high speeds. Streamlined shape. The ability of the body to restore its original shape, plasticity. Dislocations. Hardness, scratch resistance. Chemical reactions. Combustion and explosion. The laws of thermodynamics. How to turn heat into work. Thermal equalization. Why does mechanical movement turn into thermal movement? Fluctuations. Who discovered the laws of thermodynamics? 1. Gunfried Leibniz. 2. Nicolas Sadi Carnot. 3. Rudolf Clausius. 4. Ludwig Boltzmann. Tokamak machine. The way to understand the universe.
The energy of thought in its relationship to information. 1. Joseph Marie Jacquard. 2. Samuel Morse. 3. James Clerk Maxwell. 4. Noah Reeling. 5. Claude Shannon. 6. The universe as a medium for carrying and processing information. 7. Cosmic awareness, the two-slit experience. Water has memory and awareness. 8. The huge volume of data and the ability to store and measure it. 9. Data storage and retrieval on human DNA.
More knowledge about the structure of matter. The discovery of the meson and the discovery of the neutrino. What turns an electron into a proton? The properties of the forces inherent in the nucleus. Industrial radioactivity. Cosmic artillery, particle accelerators. At a new crossroads. The neutron splits the nucleus of an atom. The group of isotopes of uranium. Reaching the desired goal. Chain reactions controlled. How do we get an exact chain reaction? Atoms and billiards. Water is heavier than water. First account. Control columns or bars, and how do they work? Torch in lab. And here we suffice with this much to describe the content of the first and second sections, to start listing their details in the order that was mentioned.
Do not forget to subscribe to the channel to receive what we hope will be useful. Follow us.